Witaj Kraków! Thank you all for coming. It's really nice to see so many interested faces here who are eager to learn the new language. I would like to thank you to the Ivan too, who gave the previous talk. It was really brilliant, and it brought some basics that you could use in this talk. So, thank you, Ivan. I don't see him, but nevertheless. So now, please tell me, who is out there? Are there Android developers? And by Android developers, I mean not that you can only do Android. I mean that you also can do Android. So, Android developers? OK. Let's say Scala developers. I'm not a Scala developer. I'm just trying to help you to raise your hands. OK, so I saw 2 hands. OK. Has anyone used RxJava before? That's nice. It will be something fun for you too. OK, anyone seen Kotlin before? Wow! Guys, you prepared. I hope you'll learn something new today. OK, so let's start. Let me introduce myself first. My name is Anton Rutkevich. I work at JunaLab, a startup in Minsk, Belarus. I work with a team of 6 to 8. Now we're 8 Android developers, and we are writing an Android project for, let's say, 6 months already. So here are my primary interests. You see Kotlin, Groovy, Gradle, Mobile CI, the one button to rule them all approach, you know, the stuff. And about the project. So why am I talking about Kotlin? I have some expertise in it after writing the Kotlin project for 6 months with a team of 6 to 8 developers. So at this time, we're not switching back to Java. And there are a lot of interesting things I would like to share with you. So first, we'll start in the reverse order. I will first start with the most frequently asked questions about the Kotlin. Because if you have those questions, they will burn you from the inside during all the presentation and will interrupt you from listening to me. So I will give you first some metadata about the language itself. It's statically typed language covering the JVM runtime. It's language by JetBrains. Who knows what JetBrains is? OK, Android Studio, IntelliJ IDEA, I won't continue. It's built with effective Java in mind. There are a lot of references to effective Java that you can find in the Kotlin docs. And it's really nice. So guys really care about good and safe code. And last but not the least, the support of the community. It's not that big as one from, let's say, Scala or Groovy, but there is a Slack channel where there are about, I would say, 1,000 people, and Kotlin developers are also there. So you can directly ask your question about Kotlin or whatever. You can propose some language changes. You can give your feedback directly to the developers. And I would say that's awesome, because it solves a lot of problems right away. So it's just there. Now, history. It was announced in 2011, and it's currently in the beta. You know the joke about beta? Why the beta version is called beta? Well, because it's better than nothing. That's not the case for Kotlin, actually. But the joke is good anyway. It has been developed for 4 years. It means that it evaluated, it came away from a prototype language to a fully mature language with a lot of feedback that JetBrains continuously gathers from the developers. And now, what means that it is better? It means that it is already stable at the source level. So they won't break the bytecode compatibility anymore. And 1.0 version is coming really soon. Really soon. Well, I've heard the expectations of this year. I hope this happens really this way. So that eliminates one of the excuses of not using Kotlin, the fact that it's not yet released. So it will be released soon, and then you will have no excuses to not use it. It's bundled with IntelliJ IDEA 15. By the way, about 70,000 lines of code of IntelliJ IDEA 15 is written in Kotlin, of which only 15 are in tests. So even JetBrains trusts its own language. Even. OK, JetBrains trusts its own language, and it was built first of all to cover their own needs in a language that will be, well, better than Java. Now regarding Kotlin in the Android side. First, it gets first-class support from the Android Studio, because Kotlin is by JetBrains, Android Studio is by JetBrains, and the plugin is by JetBrains. So everything is by JetBrains. It means that it works well. Second, JetBrains understands that Android community is a big market, and JetBrains is targeting this market. So, for example, there was an issue with Dagger, with using Kotlin with Dagger. There were some complaints about this, and soon they released the capped Kotlin annotation processor tool that allowed to use Dagger with Kotlin. So they really do care. Next thing, Java interpretation is seamless. So you can call Java code from Kotlin or Kotlin code from Java in a seamless way. So just like you do it in that language. You can mix Kotlin and Java files in the single project, but you cannot mix Java and Kotlin code in the same file, like you can do, for example, in Groovy. Next one, as a consequence of the last one. So you can use all the existing Java libraries. You don't have to reinvent the wheel writing your own wrappers or something like that. You can just use all the Java libraries that you already have. And the Android pane, the 65K method limit, so it doesn't hurt really much. I will give you one more slide about the numbers. That's one of the answers to the question, why not Scala on Android? You see? So it's 50,000 methods versus 8,500 methods. So it's quite OK. So now regarding the language itself. Instead of showing you a lot of slides, static slides, we will just write the code. So basically, two things that Kotlin brought into our project was safety and clean code. And safety, I mean the new level of safety. Let's see what it is about. I think you've all seen the pyramid of testing, with 70% going to unit testing, 20% going to the acceptance testing, and 10% to the integration testing, and 10% going to the acceptance testing. But this pyramid is based on the compile time safety. The less compiler allows you, the less unit tests you have to write. Let me explain. For example, in dynamic languages like JavaScript or even Groovy, you have to check what happens if your method obtains a string instead of an int. That's hell. Guys, that's hell. In Java, it's better. So it's statically typed. You don't have to do it. But you have to check how does your method behave if it receives a null, right? In Java, every reference can hold a null. And here where null safety comes into play. So from now on, I will just code. Can anyone see what's written here? Should I make it bigger? The rows from the behind. Should I make it bigger? A little more.
That's Perl, right? Like Python.
Perl. Okay. So let's see. First, we have a fun keyword. It's a function, nothing special. Second, we have postfix type notation, actually like in Scala. Next, let's say like this. So we create a list of 5 items, 3 of which are strings, 2 of which are nulls. Then we take a random element. Actually, you see, it's not actually a string, it's a string with a question mark. It means that it can contain null. If a type can contain null, you must declare it explicitly, and it's compile time. Guys, the main thing about null safety is that it is compile time. Let's see how it works. I will type the actual types explicitly just for you to understand how it works. I cannot assign it to a string. I have to assign it to a string with question mark. Okay? So if I would like to make it a string, I would have to alter the original method. First, like this, and then element add. What's the type actual? It's a list of string with question mark, right? And how do we change this? Sorry. Yes. Now, if we want to make it without nulls, we have to trace all the nulls to their root and remove the nulls. That's the example. But let's see how do we deal with nulls. Let's bring the nulls back, and let's see how we deal with nulls. There are actually 3 ways of dealing with them. First one is not to do anything. So let's say we don't want to print this line here if we have null. We can check it like this. Like this, and do all the rest. And you can see here inside the if block, the city is already not nullable. This is a smart cast feature. So compiler knows that inside the if, string cannot contain null anymore. So you eliminate the nulls at compile time. Okay, that's the first option. Now, let's say that if we have null, we want to print the line, but we want to print just false, because null doesn't end with W. What we can do is we can use the safe access operator, just like in Groovy. It will return null if the city reference is null, and it will return the result if the city reference is not null. So what's the type, you guess? Boolean? Is it Boolean? Boolean optional, right? That's a Boolean with a question mark. And now, how do we transform it into Boolean? Let's say that we want to print false if it is null. There is an else operator. Do you know why is it called else? Turn it like this. So if that size, that expression is null, it will return false. Otherwise, it will return the expression calculated here. And the third way of dealing with, let's bring it back. So the third way of dealing with null, actually the old Java way, is to say, I'm sure there will be no null there. So that's actually what Java does. Looks ugly, right? It means that if the city reference holds a null, throw me the null pointer exception. That's actually what Java code works like. You get it? So in Java, it's implicit. So you know that there should be no nulls. And you definitely know until you hit it in production. The fun thing here is that if you write things safely and correctly in Kotlin, it looks nice. If you try to do some bullshit like this one, it starts to scream at you. 2 exclamation marks, guy, you're doing something wrong, you're doing something really terrible. And there are lots of examples of such behavior where language kind of forces you to write good code. Okay, let's switch to the next topic. It's the immutability. And it's fun, because, guys, you know what every advanced Java talk on concurrency ends with? Those big Java guys come to talk about the difficult topics on concurrency. They give a talk for 2 hours, and then they end with 2 bullet points. The first one, Java concurrency is hard. Even if you're 10 plus years Java developer, it will hit you sometime. The second one, the first one, it's hard, and if you can't, don't use it. If you can. If you cannot avoid Java concurrency, please use as few states as possible, because all the problems of concurrency comes from mutable state. So let's see how Kotlin helps you to manage immutable state. First, let's start with the reference immutability. Val is the keyword for value. Var is the keyword for variable. So values cannot be changed this compile time. You see, it's just like final keyword, but you don't have to write additional word to make a reference final. Amount can be changed, and you see it's underlined. It's mutable, it's underlined. Name is just written, and amount is underlined because it's mutable. It's a bit less safe than value. Okay. Now let's see how it helps you to work with data. Let's say we have such a Java class. That's Java. Switch back to Java. 1 class, 2 fields, 2 getters. It's verbose, but nevertheless. Let's copy it to the Kotlin code. Now you have to say wow, because that's how it looks in Kotlin. So what we have here? Here is a class. Here we have 2 properties, constant properties, and we have also a constructor which accepts those 2 properties. So now we can create a, let's rename it to just person. We can create a person whose name is John and whose age is, let's say, 26. Let me show you that we can use also such a feature like default. Let's start with the named method arguments. You can write it also like this. And this is particularly useful if you have a method where there are several parameters of the same type. Do you know the trade-off? In which order do you use them? Now you can explicitly declare it. Okay. The next thing is that you can give a default value to a parameter, and it's not needed anymore. So it eliminates the need for tons of compilers. Each of one calls another one, the standard one from Java. But okay, now we have to. You see, this class is immutable. All of its fields are immutable, so it's safe. But now we want to change it in some way. That's the first option. we can create a new class, pass the name, and pass the age. But that's a bit inconvenient. So let's write a data keyword. What does it do? First, it adds equals, hash code, and toString methods to this class. Next, it adds a bunch of copy methods. And that is the most useful thing you can do. Let's see. Instead of creating a new one, we just create John, copy, and then his age is equal to John age plus 5. So that's it. Usage of named arguments plus a copy method. How many of you are using really immutable classes in Java? Lombok does something like that, but it's still pain. So it's really nice to have such an easy way to deal with immutable data structures. And by the way, RxJava relies on the fact that you are using immutable data in your pipes. If you're using immutable data, all the RxJava pipelines try to bring some side effects and all the shit. Okay. One thing to mention is that the copy method is shallow. So it's intended to use with values only. If you have a variable here, and let's say it's not a string, it's another object, and you copy it, it's copied by reference. So be careful. Don't use variables in the data classes. Or it will hit you sometime. Okay, now let's come to the collections. Let's say we create a list of Kraków, Warsaw. There are cities, and we want to add one more to them, and we cannot, because a list doesn't have the add method. Wow, how is it? Is it really a list? Yes, it's a list. Why doesn't it have the add method? Because it's immutable. If you want to make it mutable, you have to declare it explicitly. And now you can add to it. So you see, safety first. You have to explicitly declare whether your collections are mutable or immutable. And it's all compile time again. Now let's see another example. We have a main activity, we have a toolbar. It's a variable, because it's actually initialized after the constructor invocation, and we cannot make it final. We cannot make it value. Or can we? Actually, those toolbars are, most of the time, values, not variables. So let's try to make it a value. And not nullable, by the way. So instead of writing equal to null and then doing all the stuff, we'll just call a lazy. We'll just initialize it in a lazy way. Just like that. Now you see that we don't have the question mark because it's not nullable. So it's initialized like the proper lazy value on the first access here. And by the way, set title is underlined. You know why? Because Kotlin transforms Java setters and getters into fields, just like that. Okay, now we're ready with the immutability thing, and I hope you liked it because, guys, that's cool. If you don't have much state in your app, and you don't have much state if you use Kotlin and use RxJava, then you're much safer. Now let's see how Kotlin works with functions. So Kotlin has functions as first-class citizens. You see, here is a function type. The function that takes an int as an input argument and returns an int. Here is the input. Here it is used. That's the same. So it is a built-in keyword for the first and only input argument. And you can also omit the types if they can be inferred. So once again, Kotlin is a statically typed language with a lot of type inference. If you don't see types, it doesn't mean that it's dynamic. It's just compiler can infer types at that point. Now let's see something interesting. You see the synchronized block that used some lock. Let's look inside of this method. Please ignore the inline for now. We will come there later. Note that this one parameter is a function. Function that doesn't take an argument and returns a result. And it is the last parameter of the function. So block is the last parameter of the synchronized function. So you can use the syntax like you see here. So this is one parameter that we pass, and this is the lambda that we pass to the last parameter. Just like actually in Groovy or in Scala. Okay. Now let's see another cool feature called extension function. How many of you have lots of util classes in your Java code? String utils, text utils, input utils, all the same stuff. So the idea is, if we have a function, an utility static function, which takes, let's say, one parameter, why not pass in that parameter as this argument? You copy? So instead of passing it as a parameter, pass it via this reference. So extension function is a way to add new functions to strings. To any class. It doesn't modify the class in any way. It's just the magic that creates the static functions under the hood. But the syntax is like you are using new functions on that API, on that class. For example, string capitalize. String doesn't have the capitalize method, but we can use it on the string because, you see, it's an extension function on a string object, and it can call string methods. This one is also extension, by the way. This one is also extension. Substring. It's also extension. So you see, it's all built of the extension functions. Extension functions is the, I would say, the most underestimated feature of Kotlin, because as you start seeing it, well, okay, you can add methods, but when you understand what you can do with it, it's one of the best features, I would say. So we have lambdas, we have extension functions, so why not using something like that? Have you seen this before today? Okay. It, let's say, ends with E, then map to E, it's, let's say, capital, decapitalize. And then for each, we print the string. That's it. So what happens here? That's the list. That's a regular, almost regular list. And you have all those Java 8 Stream API on it, right out of the box. There is one more interesting thing about it, but I will mention it if we have time. Okay. Now let's see how inline functions can be used to extend the API. Let's see the show method on the view. Let's see the find method on the view. The short toast method. And you know what have I forgotten here? Show, right. That's how you fix Android API. You add your own API, which is better. There's a lot of bad API in Android, and you can fix this with help of extension functions. And this one too, get location manager, for example. S is, you guess, what does S does? It's a regular cast. It's a regular cast like you can do in Java. Okay. Now we're ready with higher order functions. We're ready with extension functions. Let's take a look at one more cool feature called inlining. Any C++ or C developers here, by any chance? Or at least guys who learn C++ or have heard something of it? Okay. So, do you remember the inline directive? That's the same one, actually. What can be done with this? It actually inlines not only the method body, it also inlines the lambda. So, what we have here? We have the 10 means. Okay, we have the inline function, log, which only logs in debug. But the main point here, it only calculates the message if it's debug. Why is it important? It's sometimes expensive to calculate the message. For example, we create an exception here. It's an expensive operation. We don't want to do it in production. And if we do it like that, using the debug method, I will do the compiler's job for now and will rewrite the code as it will be in the bytecode later. So it's like that. And like that. So actually, this, what happens here is the same that happens here. So you see that it only gets executed in the debug. There are some other ways to use it, like the more general approach to the logging, the debug only execution. Do something only in debug. Or measure. How many times have you written this system current milliseconds, current time milliseconds, current milliseconds minus start, just to make a quick measurement of how much time the function takes. You just write like that. Why so? No value passed for parameter message. Okay. And that's it. So it's really a powerful concept. And actually, you remember the map, filter, all those things on the collections. They are all inlined. It means that they don't actually create any extra lambdas, any extra anonymous classes, etc. And one more cool thing about the map, about actually all the lambdas in Kotlin, is that they are non-capturing. But let's see it in another example. Not the main activity, the Rx activity. So now we came to the Rx part. We have an activity. We create an observable, just like that. That's a range. You can read it, I guess. Subscriber on next, subscriber uncompleted. And now we use it observable. We use map, filter, once again map, subscribe. You can read it. And it's actually what it does. It's not a bunch of boilerplate code like it would be in Java 7. Retro Lambda solves this, but it only solves this. And Kotlin solves much more, as you already see. But what is especially great about Kotlin and RxJava is that you can use also the extension functions. You can use functions to observable. You can add functions to observable. For example, filter positive. Just like that. So it's extremely powerful. Now you can refactor your Rx chains, and you can add your own operators easily just by combining the existing ones. I could write, for example, also a map here or flat map or whatever. So you can combine operators easily without the transform, without the lift functions, without compose, without all the things. Okay, as we have not much time left, let's see one more advanced. Guys, this is really advanced. So please take attention. Let's say that we have a token. Token that comes from server, and it can be valid or invalid. Now we do a type safety thing. We create two classes. One of these represents a valid token, and it has a value. And the other one, object is a singleton, is invalid. And this way, you, by the way, transform the string which can be, let's say, null or not null in Java, into a type-safe object. So how do you work with this? Let's say we have a list of tokens. The first one is invalid, the second one is valid, and it has a value. Third one is invalid, and the fourth one is valid again. Now we are only interested in the valid tokens. So we create an observable, we filter the valid token, and we map what comes here to the valid token. And here we can also have valid tokens. And you see, we can access its value. If we remove those two lines, we cannot access the value because token itself doesn't have a value. But now we've transformed the token to the valid token. And now it's extremely type safe. But there is one more thing. Instead of writing those filter and map, you can use this one function. Let's see. It's really difficult. First, it's inlined. Second, the reified keyword. It means that the type parameter is stored at runtime. This one is stored because of the type system, and because we inline the function, we can also store the second parameter, the second type parameter. So what happens here? Actually, the same thing that happens in those two functions. So instead of them, we just write filter type, and we give two generic parameters. First being token, second being the token valid. So we want to filter the stream so that only valid token can pass. You see? Okay. I think that's it for the demo. I hope you liked all the things you can do with Kotlin. And now let's switch back to the presentation and add some more notes. There are lots of other features I didn't mention today, but there was mentioning too. The info types, you've already seen it, the string templates, the string with the dollar signs, the properties. Kotlin doesn't have the concept of a field. Everything is a property. And if the default getter and setter are not OK for you, you can write your own. The when operator is the switch which was upgraded. And you can also write things like return if, return when, return try. And then from every branch of the execution, you have to return some value. Looks nice. We have ranges. We have unchecked exceptions. All exceptions are unchecked. We have delegates. We have operators overloading. Please use it with care. And we have type-safe builders. And we naturally have a lot of other cool things. So, there should be some downsides. I just couldn't give a presentation without noting any downsides. There are some, but I would say they are not critical. So first, tooling. It compiles a bit slower than Java. It's much faster than Scala, but a bit slower than Java. Second, IntelliJ IDEA and Android Studio is a bit less smart for Kotlin than for Java. And you have no lint. You don't need it, right? So many issues that are solved by lint are solved by Kotlin compiler at compile time. So instead of warnings, instead of lint warnings that everyone can suppress, you get a compile time error that you cannot suppress, and you have to deal with it somehow. Code. Well, it's harder to write hacky tests and hacky code actually at all. As I already said, it forces you to write code in the good way, in the safe way. And I would say the worst thing about Kotlin is that it is built on top of Java. Because Java has nulls and Java is unsafe. So most problems of Kotlin come from Java. Because when you interact with Java, Java doesn't have the null safety at the compile time. And you can get some nulls that can slip over the borders of the Kotlin code and then can explode. But you have to be, first, careful. Second, it is resolved in many cases. Dziękuję. Thank you, guys.